Hello testers and welcome to another STP community webinar. My name is James, I'm the event coordinator here at STP, and we're excited to have everyone on the webinar today. Vishnu Murty is joining us from Bangalore, India, and he'll be talking about distributed workload generator for performance load testing while using emerging technology, so stick around. A few things to go before we get started today. Coming this summer, the Mile High Software Testing Conference in Denver, Colorado. The in-person event will take place over 2 days and will include a mix of 3-hour in-depth workshops, 90-minute sessions, and 45-minute breakout talks. The event will consist of all testing topics, including agile, automation, mobile, accessibility, AI, strategy, and everything in between. So if you're ready to take your testing experience to the next level, join us July 27th and 28th for the Mile High Software Testing Conference in Denver. Visit milehighTesting.com to learn more and register for the in-person conference. A reminder that our next webinar is on July 14th from Lavina Ramchandani, where she gives you a better understanding of what data science is and how you can better structure your team in order to have confidence in the data produced. Be sure to visit SoftwareTestPro.com to register for this webinar. If you're on social media and talking about today's webinar, be sure to tag us at SoftwareTestPro and use the hashtag STPWebinar. And with that, please welcome Vishnu. We're very excited to have you today on our community webinar series. You now have control and the floor is all yours.
Hey, thanks Jim. Thanks for introduction. Thanks for joining today's presentation called Distributed Workload Generator for Performance and Load Testing using Emerging Technologies. The internal project name called JMeter as a Service. It's called JAS actually. We will know more details in the next slides. You can see my name Vishnu Murty again. The same thing which is presented. So let me give you a brief introduction about myself, what we do, what I do, and what my skills. So I'm an automation technologist group with 15+ years experience in automation efforts. I have a master's in software systems from Vishnu College, and responsible for delivering the automation tools and frameworks in DellEMC group actually. And I have worked on different domains, mainly server storage and system element software domains actually. I have 9 granted patents in USPTO, and around 128 disclosures was recognized by the Dell Patent Committee itself in Dell. I have presented multiple technical papers in different conferences from PyCon, Step-in and Targeting Quality, and other quality conferences. I also do workshops on Python and automation across conferences actually. That's pretty briefly about myself. And apart from my work, I actually work on some of the drone building activities actually. I was very passionate on building the drones, so that's where I work more some other times in the office time actually. Okay, thanks so much. Okay, so the agenda of this particular entire presentation is to make sure that what server validation group is in DellEMC, what does server validation group do, and what type of validation we do in the servers, and what is the system test. We more focused on the system test actually, or what is the system test we do, and what are the challenges we have in system test, and what are the solutions we use in system test, and the entire JAS technical stack or solution overview, and what we are doing currently, and what the next steps will be talk about in this presentation. So let me give you a small brief about this particular presentation or talk actually. Before that, this is not actually a sales pitch, because I would like to tell that my experiences and the way we build a tool with a completely open source solutions, so that anyone in this conference who are listening who can able to get benefit from these tools in their projects. That's the main thought. And the tools what we used completely open source tools, so you can able to find all the tools in internet and you can able to leverage it actually. This is purely like an educational type of thing, what we have faced and how we build this solution and how this is actually helpful for the other people. That's the main form of things. Okay, thank you guys. So coming to server validation group actually. Okay, the server validation group is geolocated in 3 different regions, in Austin / Round Rock actually, and in Bangalore in India, and Taipei in Taiwan actually. These 3 different sites we do the server validation. What exactly we do is that we validate the servers before we release to market. The servers in the data center what we use it. We do end-to-end functionality of the servers, from the software stack, firmware stack, and operating system, all the things we test, and before we release to the market actually. And we have different type of testings as part of server. Will be covered in the next slides. Okay, so I think in the typical validation or a quality, there are multiple models people use it for validating their products. In Dell also we have both models where we follow certain places in waterfall and certain places in agile. Actually, just a minute, put the mouse pointer. Okay, so you can see that there are certain products which we build. We have an agile model where we use the sprints, and then we have a hardening where we do the end-to-end testing of the sprints what we have delivered the features. And we also something called product testing where we do the end-to-end functionality test of the particular product, and then we do stability and regression. So there is a separate phase we have. It's called enterprise system testing. It's called EST. We call it. It's basically non-functional testing in industry world. What we do in the EST is that we focus more on a customer use cases and how the customer use our servers in the data center. We try to focus more on that use cases actually. Okay, so this is more like a customers focused validation effort where in the EST we do it actually. Okay, so we talk about a little bit more details on what exactly EST and how the way the EST flow and all the stuff. Why? Because the tool what we are building, what we are going to talk is more focused on the this entire enterprise system testing phase actually. Okay, so what is system test actually? The system test is more focused towards the customer validation actually. So what customer use our servers in the data center, we try to simulate the same model, same testing in our data in our labs actually. So for example, a customer buy a server, he may use a server for web workload or a database workload or a file server or a mail server. So what we do is that we try to take our new servers which we are doing testing, we put that same workload on the server and we try to stress the system with an application and see that how the way the server behaving, we actually monitor it actually. So basically what we try to do, we try to simulate the real world customer use cases on the server and see how the system is behaving or how the system is actually acting on top of the workloads. That's what we do actually. And it's a typical customer, what you call it, life cycle what the customer uses. We also try to use the same life cycle where we try to deploy the server and try to run the simulate the customer simulate the workloads on the system, and then we also try to we will be monitoring the system under this particular workloads, how it's behaving, and whenever there is any service updates or patches, we keep updating and we continue to run the workloads and monitor it. Once the system is done, once we've done the validation is over, we try to we'll be retiring the thing. Enter this effort will be in a week time, and simulating the customer workload is basically like in 120 hours of the stress we try to run on the system and see that how the server is behaving. So this is the typical what you call it in a simulation or the way the customer uses. We try to simulate in our lab on every server in a different configurations, and we try to validate the server actually. So this is the system test. So now you know the entire focus on this particular area where the simulating the customer workloads. Okay, so basically what we're trying to tell is that we will be trying to simulate what customer is going to use in the data center in our lab, so that we need to simulate with a high number of virtual users and generating high load on the system with multiple transactions. That's what the simulating the customer workload means. Okay, so there are multiple tools are in the market to simulate the customer workloads. You may be heard about Ixia, LoadRunner, NeoLoad. There are multiple tools in the market. So with that tools, what is the challenge we started facing and why we have actually built a in-house open source solution itself. Okay, that's what we're going to talk about in this particular slide, the challenges. So I think the typical challenges, correct, when we are actually buying any solution, it's very much a proprietary solution, which will be need to be installed in our local labs. You may think that why can't we use the cloud solutions? One of the challenges that we will be generating high traffic in this particular workloads, the network traffic or any traffic which will be generating, it will be very high, and we cannot able to use the cloud solutions. So we need to have an on-premises solutions actually. So when we have on-premises solutions, we need to buy this each solution every location and deploy the things, and you need to set up and we need to maintain that in the local labs actually. That's one of the major concern, because when we have multi instances in multi labs, it is going to be very licensing and costly. It will be involved with a high cost actually. That's what we're going to talk in the next point. So with this current node generation solutions which are in the market, pretty expensive. One of the major things, very expensive, the licensing. and it's also pretty complex actually because of the lab to lab and the local labs management and stuff. And the remaining 2 points are pretty much simple one. If you have any new tool, you need to have highly specialized performance engineers to develop the scripts on particular solution. If you have different solutions, you need to have different skill set and different type of engineers to develop the scripts actually. And the final one is data analytics and correlation. This is one of the key challenge what we had, because when we started using any tool, they will be giving their own data in their own format, but we wanted to have a correlation with different aspects and different information for analytics and correlation. It's become very challenging for us because we cannot able to access their data more easily. Actually, we need to use their tools to access their data than using a correlation within different tools across what we are using. Actually, this is one of the key challenge what we have as part of the current load generation solutions. So the proposed solution, what we have actually, when we started looking at this problem statement, when we were starting to build a new solution, one of the key thing what we have in our thought process is that we would like to build a solution with completely open source solutions, open source tools and solutions, so that we don't have any dependency with licensing and any proprietary tools and any proprietary things actually. So that's why we started, and I think you can see that in the slide where there are, excuse me, there are multiple technologies we used as part of this solution. Key technologies you can look at it is basically the JMeter, Docker, and Elastic Stack. All these are completely open source solutions which are available in the market. So we use these tools to build our solution. It's called JMeter as service actually. Again, it is on-premises cloud type of solution where it runs in our lab actually. Okay. And the other thing is that we wanted to build an UI instead of building another new UI and technology stack and all the stuff. We try to leverage our own in-house web UI ability. It's called Axon, where user will be providing the inputs, and the job will be executed and orchestrated and will be running. I will show you the demo where you get more details. And finally, the load generators. If you go for any proprietary tools, you need to buy the load generators from the vendors. But here, what we are doing is that we are trying to leverage our servers in the lab what we have as a load generators, and we're using that to generate the load on a systems and a test actually. Okay, so this is also one of the key thing because we can able to use any hardware or any virtualization system also, or as a load generator in the backend, because the dockers will come up in the systems and run the stress for the system under test actually. Okay, we'll have more details in the next slides, which will talk more technically how it orchestration happens. So apart from that, as I mentioned, correct, once we have the solution, couple of key advantages what we have in this solution is that it is massively scalable across regions and labs, because we have a interconnection between the labs. So we actually connected all the labs workload generators to this particular cluster, so that anyone would like to use a different sites load generators, they can seamlessly use it actually. Okay, and again, we can able to build or incorporate new workloads because it's built on JMeter, the workloads, which is basically a groovy programming language where we can able to develop pretty much like a JavaScript actually. Okay, again, this has a completely REST interface, so that you can able to use this API for external automation or any continuous integration work also you can do it actually. The final one is advanced dashboards and visualizations, because the data was generated by us, and we will be storing in our own database. So we are able to create our own dashboards, our own visualizations for a project level or a particular workload level or a particular configuration more seamlessly and more easily. So I talked same things in the previous slide also, the key technologies, and we'll be talking same thing here also. The key technologies what we use, basically the JMeter first one, the primary technology or primary tool which we use, the JMeter. Most of the people are aware of this tool. It's industry-wide, widely known tool actually. It used for the performance and load testing in the market. It supports multiple types of load tests, and it has a native load generating scripts, as well as you will find a lot of scripts in GitHub and other interfaces also. And it's again platform independent tool, so that you don't need to really about this tool can work on Windows or Linux. It works seamlessly on any platform on any way, because it runs on a completely on Java actually. And it supports multi-threading. Basically, if you want to run a spam of multi-threads of a particular workload, you can run multiple threads on the same script what you like to do it actually. And finally, it's open source software again. And the next key technology what we use is basically Docker and Docker Swarm. The Dockers are pretty widely known technology, known solutions which widely people are using, and delivering the solutions over the Dockers. Again, why? Because it's very portable and it's easy to create and dispose the containers, and very resource efficient. Because if you start using the virtualizations or VMs, again the VMs will take a lot of resources for the virtualization, but in the Dockers it will be straight away we can able to use the resources very effectively. Again, it's open source one, so that we can able to deploy the Dockers and containers. The orchestration side, yeah, there are a lot of solutions are available in the Docker's orchestration side. We have we use Docker Swarm. There is another solution called Kubernetes. You may be heard about more in the industry. So, but we stick to the Docker Swarm because it's a very lightweight and very easy to what you call as learn and use it as part of the project. And the learning curve is very less actually. You can able to quickly learn with the 3 commands. You can able to build a cluster. Okay. Again, it has a REST API so that you can able to create the jobs, you can able to orchestrate the job workloads and nodes, everything you can take it. It has one of the best thing is that it has a load balancer so that if there is any node failure happens, the containers comes to the other node and it orchestrates and it will take care of the workload and load generation actually. And the final one is Elasticsearch. This is we use Elasticsearch, our backend database, to store all our artifacts, which is generated in the entire workloads actually. So that if you are looking as a live monitoring, we can use this Elasticsearch database data as a live monitoring. Or if you want to go back and look at historical data of JMeter logs, the data is logged in Elasticsearch so that we can able to still monitor the data actually. Again, it has a REST API so that we can able to insert or read the data. Again, it's a schema free. And the best part is that it has its own distributed clusters so that we can have a high amount of traffic we can generate on the system. Finally, this is also open source. These are the 4 key technologies we used as part of the JAS primary design aspects actually. Apart from there are multiple technologies we use in the JAS, which we will be talking in the next slide. Now, in this slide, I will be talking a little more about the JAS technology stack, what we have from the physical layer to the application layer to the UI actually. Okay, so if you look at here, we're using all the Dell servers as a physical layer so that we can able to use Dell servers or virtual machines or anything we can use as part of the workload generators. Then we have using Ubuntu instead of any other proprietary OS. We'll be using Ubuntu as a primary OS for all the workload generators and all solutions. And then we install the Dockers on the systems, and then we create a Docker swarm connecting all the Docker nodes to the cluster. And we have a Harbor also, again, a open source solution from the VMware. It's a Docker registry. Instead of using Docker Hub, again, Docker Hub comes up with its own license, licensing, restrictions now, because we have a limitation of number of tools and from the Docker Hub. So we use the Harbor from the VMware. It's a open source solution. It runs our Docker images there so that we can able to pull the images as many as times from the registry. And mostly we use the two Python language, 2 programming languages. One is basically Python for entire orchestrating and a solution, and Groovy is actually written. It helped us to write the scripts in JMeter, Apache JMeter with a samplers actually. And we have a database which we use Elasticsearch for all the data to store it. Again, you can see that multiple tools you are able to see here. All tools are open source one apart from the Axon. Which is again in-house developed solution, which is basically like you can take like any web front-end type of tool where you can run where you can take the inputs from the user and run the backend scripts on your Docker section. And the Podtrainer and Jabex is basically the infrastructure clustering monitoring solutions. It's again open source solutions you will find out in the market, basically to make sure that how the cluster is running, how the clusters, when the cluster is any nodes are down in the cluster, how do we get alert and all the stuff we will be able to handle. And then we have Kibana and Grafana mainly for the users to access and visualize the data, what generated in the workload section. That's the technology stack we have. You can see most of the tools or the solutions which we use is open source apart from the Axon. Again, you can able to have your own front end, or you can use Jenkins as a front end for this particular solution and orchestrate the jobs. But as much as tools what we have in the entire technology stack is a completely open source, and what we did is that we did an integration of all these tools and delivered this particular solution for our validation efforts. Now, in next couple of slides, we will be talking more on the way the solution works and the way the orchestration or the workload generation, how the way technology, all these tools are integrated and interact with each other. We'll be talking in this next slides. Okay, so as I told you that a user will go to a front end, it's called Axon, where he goes to that particular interface and he gives the input saying that what workload we want to run, how many number of virtual users we want to run, and what is our system to be stressed actually, which will be provided. Once the request is given to the Axon, Axon actually submits the request to the workload generators, as well as it also updates this information to the Elasticsearch. So the load generators basically is a pool of systems. It is a Docker cluster full of Docker systems actually, where whenever we ask a virtual users, the containers will come up on the Docker nodes in a distributed load balanced manner. And each container have the JMeter script which supposed to be stressed actually. What is the application, what type of stress you wanted to run will be having in the container, and it will be started with JMeter. Once the JMeter is started, basically the containers will have the JMeter load generator script which will be stressing your application or a test using over the network infrastructure actually. So that the containers will keep on generating using the virtual threads in JMeter will be keep on generating the load on your systems, and at the same time all the data which is on the containers will be stored back into Elasticsearch, as well as the system whatever the events is generated will be stored into Elasticsearch. Why we have storing in Elasticsearch? One is that user can able to use this data for the live monitoring. At the same time, once the job is over, the containers will be removed from the load generator, so that you will not have any more access on the containers data. So that due to that, we would like to store all the data what container is generating into the Elasticsearch, so that user will able to have a live monitoring as well as historical data analytics from the Grafana web interface actually. So this is the way the entire end-to-end orchestration happens from the user where he will given the inputs in the Axon to the way the containers comes up into the load generators, and the containers starts the JMeter script and stressing your systems under test. So the entire ecosystem is having multiple tools, but they interact over the database and connections and communications and run the workloads and get access all collect all the data from the containers and systems and storing into Elasticsearch actually. So we talked about the way the high-level orchestration happens, but we would like, if you would like to know more details about the data flow, how the way the inside the what you call it container, what it do, how the way the data flow happens between all these tools and communications, we will be talking in the next slide. So at the initial in this picture, you can able to see the Docker Swarm. Docker Swarm is basically a Docker cluster which contains in Docker Swarm terminology, it's called as managers, basically the job orchestrators, and workers, basically the load generators in this particular picture. So when a user goes to Axon, a web interface, and he submits the job will be the Axon will create a Docker service in the Docker terminal. It's called Docker service. It creates a Docker service in the Docker cluster, in the Docker Swarm cluster, as well as Axon also pump all this information into the Elasticsearch, basically in the database. What is the Docker service details and Axon workflow details and the workload JMeter workload details also. Every information what we would like to communicate next steps will be stored into the Elasticsearch database for the future usage actually. So in the Docker Swarm, basically the Docker service is basically like a number of tasks or number of containers or number of virtual users. You can use this any terminology actually. So we consider that service is basically like a virtual users creator. So when you say Docker service, I want to run 2 users, basically there will be 2 containers will come up across the load generators in a distributed manner. So the JMeter Docker container, you can say that what is the JDC basically, the JMeter Docker container. Once the JMeter Docker container is similar to like in a virtual machine or any other technology. So the JMeter Docker container, what it does is that it goes back to the database and collects all the information from the database, what type of workload we need to run and what is the Docker service information, all this stuff. So once the JMeter knows the JMeter Docker container, get to know the JMeter script information, it uses the JMeter script and loads into that container actually. So basically it runs the JMeter script from the container itself. With the script, it actually starts stressing the server. So we will be already populating all the information about the server details in the JMeter script, and the script will be downloaded into the container using from the database and starts the script. The script basically starts generating the load on your system. So at the same time, the JMeter Docker container also generate a lot of data, basically the JMeter logs or container metrics and container logs. All this data live in the live manner is streamed back into the Elasticsearch database, so that the container, whatever the container is generating, we don't need to go to container. We can able to access the data from the Elasticsearch itself. So at the same time, all the server, all the system or application level data, for example, you have software logs or hardware logs or OS metrics and OS data. All this data also we collect from server and we store it into the Elasticsearch, so that we can able to correlate what was happening in a container level and how the way the server is responding to the particular workload. So this way the entire workload will be orchestrated and it will be generating the load on a system as many as users requested by the end user actually. So one of the key advantages from this solution is that it has something called as a dynamic profile workload generation actually. What it means is that initially we may be started with two virtual users and there may be a system utilization of roughly around like 60 to 70%. But we would like to increase the workload actually. For example, we would like to increase the stress on a system, stress on your system. So technically what we need to do is that we need to increase the number of virtual users. So this particular solution have an ability to increase the virtual users dynamically. What it means is that user will go back to Axon again. He says that now I am running two users, I'm getting 60% utilization. Now I'd like to increase the virtual number of virtual users from 2 to 3 actually. So he can able to go back and update the information in Axon. And Axon will be updating the same information into the manager Docker service. With the Docker service, when it says update to number of users from 2 to 3, the Docker service brings the new container in a new load generator in a distributed manner. So once a new container comes up, it has same data flow where it gets the data from the database and starts generating the load and sending the data to the database actually. So this way we can able to seamlessly increase the number of containers, number of virtual users dynamically, or we can able to reduce number of virtual users dynamically with this solution. So this way we can able to say that morning to evening we would like to have more number of users, again night we would like to reduce them less number of users, like in how the way the customers the systems and data center behave, we can able to simulate the same profile the same way with this type of scale up and scale down number of virtual users actually. So now we talked about the data flow, how the way when the user goes to Axon, when he submits the job, the containers will come up into the load generators and it starts stressing the system under application under test actually. But now we are also talking about the scalable across labs and seamlessly able to run across geosites and geolabs. So this is the slide which will be explaining that particular situation. So when a user goes to Axon and he says that I would like to run this particular workload on this particular BDC lab, Bangalore Development Lab, or Austin Development Center, whichever the lab you would like to know, whichever the lab you would want to run, we can able to select it. So what technically we do is that we submit the job to the Docker cluster. In the Docker cluster, the Docker nodes are actually geotagged using the location names. So the Docker cluster itself orchestrates the containers based on the lab which we are selected. So we have not implemented any new solution. It basically comes from the Docker swarm itself as a feature where we can able to tag the nodes. And when we submit a job, we can able to choose the label of the node locations, lab location, so that the new containers will actually orchestrated in the same lab location what we selected. So this way, what we have done is that we are able to geo tag the nodes in different sites, so that the containers will be come up in their particular lab and they can able to run the workloads. This way, we are able to restrict the network traffic in a better way because we are not running a cross sites load generation. Users are able to run the workload seamlessly on the load generators which are available in the particular geosite. So this way, the Austin development team no need to deploy another JAS solution for their own usage. We'll be using a common JAS solution, but we are actually geotagging the nodes on respect to their labs. So the containers will come up in the lab and they're able to help us to generate the load in the system section. In the next slides, we'll be covering a little bit more details about the what workloads, what type of customer workloads we have, and what is our future workloads we are working on the things. So up to now, we talked about all the solution, what tools we used, how the way the high level orchestration happens, and how the way the data flow happens between the different solutions and different tools. Now we're going to talk about the workloads what we have. These are pretty much like an rejuvenate scripts actually. So we have covered wide variety number of workloads in this particular solution. We have basically if you have a server or it runs an Apache RIS, we have a CS workload which runs to stress your web application using multi-users and multi-threads. The web application could be anything, any type of application. We can able to run the workload using the GMT scripts and stress it actually. And then we have a couple of more workloads which is more specific to a network and disks component stress actually. For example, if you have an FTP or if you're an SMB workload, which basically focus more on a network and disk utilization, high disk utilization and high network utilization. These workloads help us to run heavy traffic on the network and the disk actually. And we have a mail workload, which is more focused on CPU, memory, and disk, all the things, because you may have a user may be running a mail server on a MS Exchange or a SendMail. You can deploy the same application on your particular system, and the JAS will able to generate high traffic over the SMTP protocol on your system and see that how the system is going to behave. And finally, we have high number of database workloads. Basically, the database workloads we cover from the MySQL, MS SQL, Oracle, Mongo. All these workloads we have because each database behaves differently, and some of the databases are having called in-memory databases, so that they will be in the RAM actually. So we cover all these databases, and we also support all these workloads, database workloads from the JAS actually. These are all purely JMeter scripts. We also have a new workload called OmniSky. It's more focused on the GPU controllers. If you have a GPU controllers on the system, we can able to use this particular workload to stress the GPU cards actually. This is recently we built to stress the GPU GPU cards actually. Okay, so now I would like to give a high-level demo of this solution, and I know it's pretty. We recorded this solution. We recorded this entire demo, and it's a very short demo. Let me cover it. So for the demo purpose, we are actually using the web server, where we have a random number generation on the web server, so that the web server will be actually opening the web website, and it generates a random numbers, which actually generate a high CPU load on your system actually. Okay, this is just for a demo purpose. We are showing this particular workload. Okay. So you can see that this particular web, basically a CPU PHP web server, which is running a random numbers of 1,000 random strings it generates, so that it will be generating a high CPU stress on your system actually. So this is the Axon front end, which I mentioned, where user can able to provide inputs. This is just like a lightweight front end for users to provide the inputs, so that the inputs we will take from the user and run the job in the backend. So the main inputs, like you can look at the project name and all the stuff. The key inputs are basically we ask that the web server path and the number of virtual users we would like to run, and the location, the lab location where you would like to run this particular workload. So these are the key inputs where we would like to know that what is the web server details, how many threads you would like to run, virtual users you would like to run, and which location you would like to run this particular workload. We take this information from the user, and if we also take some of the information like a tags or any fields user wanted to provide to group the configuration detail, we take that information from the user. And once we provide all this information, the Axon is our internal, what you call it, automation solution, where it actually create the process of executing the things what we would like to run. So in this particular workflow, what you can see is that it try to verify that entire inputs what user is provided, and then it given a sub workload the details. Basically, that sub workload will create the Docker container, Docker service, and update the data into database, and all the stuff will take care of the back. So now, as Axon took the input from the user and update the data into the database, and it also created a Docker service. So as I mentioned, Portal is basically for the Docker cluster management solution. You can see that a specific service is created by the user. That particular Docker service was created in the backend, and with a one virtual user. So what basically is that it creates one container with the JMeter loaded, and with the web script is loaded in that, and it starts testing your system actually. Okay, so once the JMeter started running in the container, it starts hitting your web server with a particular endpoint. You will see that the utilization is increased on your system, the CPU utilization is increased. So this way the user can able to seamlessly run the workload from the web front end and able to monitor the same data from the Grafana, which will be showing the next. So we have a small web interfaces where we will be showing that what job you ran, how many containers you asked, and is that all the containers that came, and how many days it is running from the, how many hours it's running, how many threads we are running. All this information show here, and also we have a Grafana dashboard which will give you the timeline view of entire JMeter data actually. For example, number of transactions you ran with the JMeter, number of errors it generated, how the way the number of average transaction speed for the workload you will see from the Grafana. All this data which is generated by the JMeter, we will pumping into the Elasticsearch and visualizing the data into the Grafana. Okay, so this is the way user can able to orchestrate the workload and able to stress the system application what you would like to run with the number of users. Now we are getting around like a 66% utilization, and now we would like to increase the number of virtual users. We will go back to Axon again, and sorry. Okay, we go back to Axon again. We'll update the number of virtual users from the 1 to 2. Now we have 1 user. Now we would like to increase 2 users. Once we increase the number of users to 2, Axon again update this information to the Docker cluster. Basically, we can able to see from the same information from the port runner. So now previously we ran with 1 user. Now we are increase the number of users from 1 to 2. Basically, it creates now 2 containers. Already 1 container is running. It's stressing the system. Now new container will come up. It starts stressing the system with the new workload actually. Same, and you can see the same thing reflecting the same number of containers in the web portal. And once the new container comes up, it's same thing. The new container will again go back to the database, get the information about JMeter script, and start running the JMeter script with the JMeter application actually. Once the JMeter application starts stressing with the system, you can see that the CPU utilization increased to the 99%. This way, the user can able to scale up or scale the number of virtual users dynamically based on the use case. So now as I mentioned, we update the same information into the database, and you can able to monitor the same data from the Grafana also. So you can see here the number of virtual users increased to the 2, and you can also see the average transactions and all the error percentage of the workload what you are running. Again, I'm doing the back. Okay, so once the workload, we complete our testing on the workload, we can able to go to Axon again. We will able to say that okay, we would like to stop the workload. Once you stop the workload, basically what Axon will do is that it goes to the Docker cluster and delete the particular service what is orchestrated in the Docker swarm. And then once the Docker service is deleted, automatically the container will be removed, and you will not see the particular job in the dashboard, active jobs in the dashboard. Again, once the Docker services get deleted, the containers from the respective Docker service also get deleted from the Docker cluster. And once the container is no more available, there will not be any more load on the system, and you can see the dip in the system utilization. Okay, so this is the way the life cycle of the entire what you call JAS solution works, where user can able to start the workload, and user can able to dynamically scale up and scale down the particular number of users on the workload, and you can keep monitoring this information from the Grafana, whatever the workload is running with the JMeter transactions and information. Okay, and whenever he is done with the workload, he can able to go back and stop the workload, and automatically all the data respect to the containers, everything will be removed, and the workload will be stopped actually. But all the JMeter logs and container information, everything about the workload is stored in the database for the historical analytics also. Sorry. Okay, so what next we are working, basically now if you look at it, whatever the workloads you've seen, it's pretty much like an standard workloads, and we have used these workloads in different tools, and these are industry-wide known workloads. We also working on the new workloads, like you have a version control system on this application deployed on the server, how the way the different version control operations will actually impact your server performance and how the way the server behaves, as well as a lot of systems are buy for the video streaming or social media or machine learning projects. We also would like to create this type of workloads and run it using JAS on the systems which we actually released to market, and see that how the way the systems, how the way this entire workloads actually running on this particular new generation workloads are running on our systems and behaves on the same thing. We would like to monitor. These are the new workloads which we are working. A couple of years we are working on the same thing. Okay, so in the end, what we have done basically, this is a project we started in 2017, or we have got a first first what you call like release in 2018. From the last 3 years, we ran this project extensively in different releases. Okay, so just in high level quick numbers for you guys to understand how the scale of this solution we're using. So basically we have around like an 85 load generators across globe right now, which can generate around like a 2000 virtual containers. Again, we have virtual threads inside that. It will increase number of virtual threads. Again, we use 90 plus projects, number of users which accessed, and all the stuff. So all in all, this particular project which actually help us to save around like $1 million dollars of operational expense every year, and over the last 3 years we saved around $5+ million of the investment actually. Because this is completely, we use the open source solutions, we reuse our Dell servers to generate the workload, and whenever we have high specification systems, when it comes up, we use our servers itself to generate that much of load for our workloads actually. So this way we are able to repurpose some of the servers, and we also build a completely open source. We use the open source tools to build a solution, so it's pretty helpful for us to get the things done. So that's pretty much from my side, and I would like to know if you have any questions and answers. I would like to take it.
Awesome, great presentation, Vishnu. We do have a couple questions if you're ready.
Yeah, absolutely, sure.
All right, from Nitesh, is there any way we can directly run a JMX file? And he actually has a second question. It says, is it possible to run JMX file in different system in cloud? Is this feature available?
I mean, if you look at it, the JMX file you can able to run anywhere in the VM or a container, anywhere in the system actually. Okay, you can take a simple Docker container, you can take a simple VM, or you can say able to take any cloud, Amazon or anywhere you can able to have a cloud systems and you can able to run it actually. Then JMX is a pretty widely open one, and you can have the JMX file, which is basically your workload script, and run it from anywhere actually. That's absolutely correct. Yes.
Okay, perfect. Another question, last question here. What do you see as the biggest challenge facing workload generators as the number of internet users increases?
Can you repeat again? Sorry.
What do you see as the biggest issue or challenge facing workload generators as the number of internet users continues to increase?
Yeah, one of the major challenges, if I look at it, is that the number of workload generators, as we mentioned, correct, when we have number of users are increasing, we need to have more number of workload generators. The estimating this stuff, okay, how many users we need to have this particular application is one of the key challenge, especially when you have more number of virtual users and more number of load generators required. Okay, that was one of the key things. We also have the same challenge. How do we estimate how many load generators or how many virtual users is required for a program or for a number of projects actually? That's one of the key challenge. We're still working on some of the tools to estimate that stuff using the historical data as well as the Docker capacity and planning actually. Okay, so I'm not really sure I answered it, but yeah, it's a little bit difficult to identify the things, but over the time we are actually learning the things from the data what we have, and we are actually predicting that stuff.
All right, great answer. Nitesh has, can you show a demo how we can use Axon and DellEMC services to run JMX in different Docker?
I mean, in the offline I can able to cover it, because in the demo what we have done is that I think one thing is that if you look at it, right, before the solution we started using, we used to have the VMs having JMeter application with the JMX files as inputs, so that the engineer used to go to the VM and reserve the VM, and he used to put the JMeter script into that VM in the JMeter and used to run it. So what we understand is that instead of exposing our infrastructure to the end user, we actually created this particular what you call a technology stack or an interface where user will come to the inputs, and we will be creating the JMeter file, and we will be uploading the container, so that we actually abstracted that entire layer from the end user to access on the infrastructure actually. So I can show you, if you guys wanted some offline, I can able to give you the demo on the same thing how it works out, but it's pretty much like in how the way that Dockers will actually run an application, whichever we would like to run it in the container, correct? The same way it will actually JMeter also runs it.
Awesome. Yeah, if you want to reach out, Vishnu, you can.
Yeah, you can actually reach out. Yeah. Yeah, you can feel free to reach out, because we also reaching out to community whenever we have some challenges in the JMeter, challenge in Elasticsearch, or a challenge in the Docker cluster. We always look into the community, and we always search in the community for understanding these things. I think this product was actually built over the last 3 years with the learnings from the community and the learnings what we got it from the system actually. So yeah, that's absolutely fine to reach out to us, and we can able to help with the things.
Awesome. Thank you so much, Vishnu. What a great presentation today. And we hope to see you soon, hopefully in person at a STP event soon.
Thanks, guys. Thanks very much. Thanks for your time. And thanks for joining the presentation.
All right. Just before we go today, just a couple of reminders. Coming this summer, the Mile High Software Testing Conference in Denver, Colorado. The 2-day in-person event will take place on July 27th and 28th, and we'll cover all things software testing. Check out the workshop sessions and track talks that make up the in-depth program, and register at milehighTesting.com. Also, our next scheduled webinar will take place on July 14th. Lavinia will be giving a presentation on testing a data science model. Visit SoftwareTestPro.com to sign up for this webinar. And thank you, Vishnu, and everyone else who joined us today. Have a great day and stay safe.
Thank you, guys. Thanks so much. Thanks for joining.